Today we'll be going over Notes 11.2, Right-Angled Triangle Trigonometry. Most of this should be review, but if there's things that are new, hopefully this will help. So first we'll be going over sine, cosine, tangent, and the most important thing to remember is SOHCAHTOA, which you guys should already know, but in case you don't, we'll go over it. And SOHCAHTOA stands for sine of an angle equals opposite over adjacent, which you can see up here. Cosine of an angle is equal to the value of the adjacent side over the hypotenuse, and tangent is equal to opposite over adjacent. Okay, so next we have some of the basic values of the sine, cosine, and tangent of common degrees of 30 degrees, 45 degrees, and 60 degrees. You can see these by using SOHCAHTOA and these 45, 45, 90 triangles, and also the 30, 60, 90 triangle. But what you can also see it from, and you might remember it because of this, is the unit circle, which is something you should definitely remember. If you think back to the unit circle, you know that the sine of 30 degrees is 1/2, and cosine is rad 3 over 2. Sine and cosine of 45 degrees is rad 2 over 2, and tangent has those values that you can derive from the unit circle as well. So it's definitely important to remember the unit circle. All right, and first we're going to go over the angles of elevation and depression. So I'll just underline some terms here. But the terms angle of elevation and angle of depression are often used in word problems, especially those involving people as they look up at or down on an object. So as you can see from this image here, the person, if he's looking up, that's the angle of elevation, and looking down would be the angle of depression. So yeah, it says when looking up, the angle of elevation is the angle up from the horizontal and the line from the object to the person's eye. And when you're looking down, that would be the angle of depression, which is the angle down from the horizontal and the line from the object to the person's eye. So just a quick kind of example of how a word problem might be phrased for this type of problem. Let's say it tells you that there is a person, and say he's looking up at the top of a tree, right? And let's say that it gives you the distance between the person's eye and the tree, and it also gives you the angle of elevation, because in this case it's looking up, right, to the top of the tree. So let's say it gives you that the angle of elevation is 40 degrees, whatever, and we know that, the tree, we'll just say that it's straight, so we can make that a straight line to the distance between the person's eye and the tree. That would make a 90-degree angle, so we know we can use SOHCAHTOA, because those can only be used with right triangles. And since it gives you this distance between the person's eye and the tree, let's say it wants you to find the distance between the person's eyes and the top of the tree. So we would want to find this length right here. Oh, I should probably give the other one a value and call this one x. Let's say it told you that the person's distance between the person's eye and the tree was 5 meters. Then x, we know that cosine of an angle is the adjacent over hypotenuse. So in this case, cosine of 40 degrees would equal 5 over x, and you can solve for x from there. All right. Okay, now let's talk about bearings. So a bearing is used to indicate the direction of an object from a given point. So direction is important, and from a given point. So there are two different types of bearings. There's 3-figure bearings, and there's also compass bearings. So 3-figure bearings are measured clockwise from north, and can be written as 3 figures. On the other hand, compass bearings are measured from either north or from south, and can be written such as N 20 degrees E, which would be translated to north 20 degrees east, or 20 degrees east of north, and so on, and where the angle between the compass direction is less than 90 degrees. So if we look at this example that they provide, the angle represented in green would be the three-figure bearing because it is measured from north and it's in the clockwise direction. And the blue would represent the compass bearing, which is written as S 60 degrees W, or south 60 degrees west, or 60 degrees west of south, because it is closest to the south and it is moving west. So we would measure it from the south axis, and that is 60 degrees towards the west. All right, lastly, we have the formula for an area of a triangle, and this doesn't have to be a right triangle, so it's very useful, and you definitely should remember it. Just to draw it out, if we have a triangle, sides A, B, and C, and we have angles A, B, and C, the area of a triangle is equal to 1/2 of A times B, so any two sides of the triangle, and the sine of its included angle. So in this case, we have 1/2 times A times B and its included angle, C, and the sine of that included angle. But it could also be, in this case, it could be 1/2 A times C sine B, or 1/2 BC sine A, right? So that is definitely a formula that you should try and remember. All right, now we're going to go over a couple practice problems. I'll probably go over a couple and I'll let you guys figure out some of the other ones just because they're pretty easy. So I'll go over the first one. A safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the maximum safe rescue height? So when working with right-angled triangle trigonometry, it's definitely important to first draw a picture. So we know we're trying to find the maximum safe rescue height. So let's just draw a line to represent a certain height. And since we're working with ladders, they're usually put up against a wall. So we would use this as our ladder, and let's just connect it and say that's the ground. So since we know that the angle between the wall and the ground is 90 degrees, we know that we can use SOHCAHTOA. We're given that the longest ladder, or the ladder that we're going to use in the problem, is 110 feet. So we know this is 110 feet. And that the angle of elevation, notice elevation because it's going up of the ladder here, is 72 degrees. All right, and we want to find this maximum safe rescue height. So think SOHCAHTOA. Which one should we use? Hopefully you think sine, and you would say sine of 72 degrees is equal to opposite over hypotenuse. So opposite would be the height over hypotenuse, which was 110 feet. And if you multiply it out, multiply 110 by both sides, you would get h equals 110 times sine of 72 degrees. Plug it into your calculator, making sure that it's in degree mode. You would get h is approximately, and if we use 3 sig figs, we'd get 105 feet. So that would be the maximum safe rescue height. All right, for this next one, I'll let you guys try on your own, but as you can see, we're going to be talking about bearings. And so when working with bearings, you should definitely always start with a picture, of course, and using a north, south, east, and west graph. All right, and I'll go over example 3, which is to find A and B. So we're given a triangle, and we need to find the side lengths of A and B, but we know that we actually have two triangles here. We have a bigger triangle, and we also have a smaller right triangle inside it. And since we're given that those two are both right triangles, we know we can use SOHCAHTOA, but we have to figure out what are the steps that we want to use. So hopefully you think, okay, I have one of the angles of the right triangle here, and I also have the sine length. So we'll probably go for the bigger triangle and solve for A first. And hopefully you think to use tangent. Since we have, or we're trying to find the opposite and we have the adjacent value of the 40 degrees, we can say tan 40 degrees is equal to opposite, which is A, over 12. Multiply that out, you get A equals 12 times tan 40 degrees. If you put that into your calculator, you should get that that is about 10.1 centimeters. Forget units. And then now that we have 10.1 centimeters, you might think, okay, how can we find B? And it might be a little confusing because you see that B is the side length of a triangle that is not a right triangle, so you can't use SOHCAHTOA. But since we know that this is 12 and we know that this is a right triangle, we can find the side length of that right triangle. Let's just say X, and we can find B using B equals 12 minus X, because that's the value of the length of the bigger right triangle minus the length of the smaller right triangle. Alright, so in order to find X, we will use tan again, and hopefully you get that tan of 60 degrees is equal to, again, opposite over adjacent, so A over X. And now that we know the value of A, which is 10.1, we can solve it out, and we get that X is equal to 10.1 over tangent of 60 degrees, and that is about 5.81 centimeters. But don't forget, that's not our final answer. We need to plug that back in because we're trying to find B and not X. So B would equal to 12 minus 5.81. And that would get you about 6.19 centimeters. Alright, and this last one is pretty simple. Just find the area of the triangle, and I'll give you guys a clue. We're going to use the equation that we just learned, A equals 1/2 AB sine C. Alright, so make sure to solve example 2 and example 4 and look at the key when you're done to check to make sure you did it right. And don't forget the angles of elevation and depression, and also the two different bearings, 3-figure bearings and compass bearings, and to remember the formula for the area of a triangle.